Hi folks, I hope you're having a great day at school today. I'm going to go through the answers to your homework now, so if you want to take them out and correct as I go through it, I'll give you a second or so to get them out. So, the first question you had was 6x squared minus x greater than 15. First thing I'm going to do here is bring the 15 across the inequality sign to get 6x squared minus x minus 15 is greater than 0. We're now going to follow the steps of our solving quadratic inequalities that we had yesterday. First thing I'm going to do is replace the inequality sign with an equal sign, giving me 6x squared minus x minus 15 equals 0. We have a quadratic trinomial, so we're now going to factorize this, solve it, and draw a graph to find our solution set. So, our two factors here will be 3x and 2x, and we have 3x minus 5 and 2x plus 3. We let both factors now equal 0 to give 3x minus 5 equals 0, or 2x plus 3 equals 0. Given us 3x, subtract 3x equals 5, so x equals 5/3. We also have 2x plus 3 equals 0, therefore 2x equals minus 3, x equals minus 3 over 2. I'll now draw a very rough sketch of this graph from what we know and find our solution set. So our xy axis, 1, 2 on the x-axis, minus 1, minus 2 on the x-axis also. So we know that the graph of this equation will cross the x-axis at minus 3/2, which is approximately here, and 5/3 approximately here. Okay, so it will be something like this. Now, we are looking for the x values that make this inequality greater than 0, i.e. this means where the graph is above the x-axis. So these values of x will give back positive values for y. Therefore we have our solution set. The solution is x can be less than -3/2, or x can be greater than 5/3. That's question 1 done. Now we're going to look at example 2. Example 2 says 16 subtract x squared is less than or equal to 0. Okay, so we see the coefficient of x squared here is a negative. Now we can factorize a negative x squared, but I think it's easier to make it positive. So I'm going to multiply this inequality by -1 to give me x squared minus 16 is less than or equal to, when we multiply by a negative number in inequality, the inequality sign switches over, so I now have x squared minus 16 is greater than or equal to 0. Okay, it should be obvious to you that this is a quadratic binomial, and it's to factorize this we actually have the difference of two squares. We have x plus 4 and x minus 4 is equal to 0, because 16 is the same as 4 squared. Okay, so let's now solve. X plus 4 equals 0, so x equals minus 4, or x minus 4 equals 0, therefore x equals 4. We now have our two solutions. Let us plot a rough sketch of this graph. So we have our xy axis again. 1, 2, 3, 4, 5, 6. On the positive x, minus 1, minus 2, minus 3, minus 4, minus 5 on the negative x. Okay, we know this graph crosses the x-axis at 4 and -4. So our graph will look something along these lines. Now, we're looking for the values of x that make this graph greater than or equal to 0, i.e. above the x-axis. These values of x here and so on will give back positive values for y. Therefore, the solution set is x can be less than -4 and x can be greater than 4. And I just noticed that my original inequality sign is actually greater than or equal to, therefore I should have had x can be less than or equal to -4 and x can be greater than or equal to 4. Okay, let us look now at example 3. We have 2 bracket x squared minus 6 greater than or equal to 5x. Okay, before I do this, I'm going to multiply out the brackets to get 2 by x squared is 2x squared. 2 by minus 6 is minus 12, greater than or equal to 5x. And again, I'm going to bring the 5x across to have 2x squared, subtract 5x, subtract 12 is greater than or equal to 0. Now I'm going to replace the inequality sign with the equal sign. 2x squared minus 5x minus 12 equals 0. And I'm now going to factorize this and solve. So I have 2x and x, factors of 12 and a combination of 2x and x to give me minus 5x is 2x plus 3 and x subtract 4. Allowing these factors both equal 0, I have 2x plus 3 equals 0 or x minus 4 equals 0. 2x plus 3 equals 0 gives me 2x equals negative 3, x equals negative 3 over 2. And x minus 4 equals 0, therefore x equals 4. And again, let us draw our graph. Rough sketch, where x, y axis, x, y, and 1, 2, 3, 4, 5 on the positive x, minus 1, minus 2, minus 3 is all we need on the negative x. And we can see from our roots that the graph crosses the x-axis when x is 4 and when x is minus 3/2 or minus 1.5 approximately here. So our graph will look something along the lines of this. Okay, and what we're looking for is where 2x squared minus 5x minus 12 is greater than or equal to 0. The values of x that will allow this to happen. Well, if we look across our graph, these values of x here and these values of x all along here and so on will make the function greater, the inequality greater than or equal to 0, given the solution as x can be less than or equal to minus 3/2 and x can be greater than or equal to 4. This moves us on to question 9 and 10. Now I'm not going to do every single one of these because they're done all very similar. We're going to pick out some of them. So I'm going to start with 9 part I. We have x plus 3 over x plus 2 less than 2, where x cannot be equal to minus 2, because if it was, we would have 0 on the bottom, which we know we're not allowed. Okay, so we're going to multiply across here by x plus 2 to be squared. X plus 3 all over x plus 2 less than 2 by x plus 2 squared. And as we said yesterday, the reason we're multiplying by x plus 2 all to be squared is to ensure that that is a positive number, therefore the inequality sign does not have to be flipped. So on the left hand side we have a common factor. X plus 2 goes into itself once, leaving me with x add 2 by x plus 3 less than 2 by, well, we have a perfect square here, so we square the first term, gives us x squared, Twice the first term by the second term is 2 by x by 2, which is 4x. Last term, which is 4. Okay, so x by x is x squared. X by 3 is 3x, plus 2 by x is 2x, giving me 5x, and 2 by 3 is plus 6, less than 2x squared. 2 by 4x is 8x, and 2 by 4 is 8. Okay, so now I have terms on both sides of the inequality. I'm going to bring them all to one side, and I see that the 2x squared side on the right hand side has more x squareds than on the left hand side. Therefore, to keep the coefficient of x squared positive, I bring all the terms on the left over to the right to give me 0 less than 2x squared minus x squared plus 8x minus 5x plus 8 minus 6. So simplifying the right hand side, I have 0 less than 2x squared minus 1x squared is x squared, 8x minus 5x is 3x, and plus 8 minus 6 is plus 2. And that's the same as x squared plus 3x plus 2 is greater than 0. Okay, so I'm now going to replace my inequality sign with an equals 0, and I'll factorize, giving me x, and the factors of 2 that will add to give me 3 is plus 1 and plus 2. So that gives me x plus 1 equals 0, therefore x equals minus 1, or x plus 2 equals 0, therefore x equals minus 2. So we now have the two roots of this equation, also known as the critical points of the inequality. So I'm going to graph, rough sketch. It's all on the negative side, we can see here, of the x, so minus 1, minus 2, minus 3, and put in 1 there. Okay, so the 2 points are minus 2 and minus 1. We'll draw a rough sketch then of the curve. Will be something like this. Okay, now we are looking for the points where x squared plus 3x plus 2 is strictly greater than 0. So these will be where the x values give positive y values in the function, which are them x values, where the graph is above the y-axis. So the solution then, the solution set is less than minus 2 or x greater than minus 1. Now I'm going to do 10 part 3, which gives us 3 add 4x over 5x minus 1 greater than 3, where x cannot be 1/5 because it would make the denominator 0. Okay, so again, follow the same steps. We're going to multiply each term by 5x minus 1 to be squared by 3 plus 4x all over 5x subtract 1 is greater than 3 by 5x subtract 1 all to be squared. Again, on the left hand side we have a common factor here, going to itself once, leaving me with 5x subtract 1 by 3 plus 4x is greater than 3. 5x minus 1 is a perfect square, so we can square the first term to give us 25x squared, twice the first term by the second, which is 2 by 5x is 10x, by 1 is negative 10x, and square the last term, minus 1 squared is plus 1. Okay, so multiplying out the left hand side, we have 5x by 3 is 15x, 5x by 4x is 20x squared, negative 1 by 3 is negative 3, negative 1 by 4x is negative 4x. Less greater than 3 by 25x squared is 75x squared, 3 by negative 10x is negative 30x, and 3 by 1 is plus 3. So, looking at what we have, I'm going to simplify the left hand side. I've got 15x minus 4x is 11x, so I have 20x squared plus 11x, subtract 3, greater than 75x squared minus 30x, add 3. I'm going to bring all terms to the right hand side because there's more x squared on the right hand side, which will ensure the coefficient of x squared will be positive. So that gives us 0 on the left hand side, greater than 75x squared, subtract 20x squared, minus 30x, minus 11x, plus 3, giving me 0 greater than 55x squared, minus 30x minus 11x is minus 41x, plus 3 is plus 6, and just that is the same as 55x squared minus 41x plus 6 is less than 0. Okay, I'm now going to replace my inequality sign with an equal sign. 55x squared minus 41x plus 6 is equal to 0. We now factorize this to get 5x minus 1 and 11x minus 6 equals 0. Giving me 5x minus 1 equals 0, 5x equals 1, x equals 1/5, or 11x minus 6 equals 0, 11x equals 6, x equals 6 over 11. I'll now make a sketch of the graph. So we have our x and y axes. Here's 1. In fact, I'm going to make 1 further across because both of these values lie inside 1. We say 1 is there. X is 1/5, so approximately there. X can then be 6/11, just over a half, approximately there. And let's sketch what we have. So there's a graph. And we're looking for the values of x that make this function less than 0. In other words, where it's below the y-axis, which are these values here. Between this value and this value, these two x values, we're looking for the values between the two x values here. So that makes our solution, the solution is x can be greater than 1/5 and strictly less than 6 over 11. Okay, I want you to now have a go at the following question, so you'll need to pause this video. There you go. Questions 11 and 12.